Hey there, StudyBuds! We are back again with another episode about angles. We will be learning about complementary angles, supplementary angles, vertical angles, and some theorems. Don't forget to subscribe in our channel so you can't miss any Tutorial Tuesday episode. We have specially made these videos for you every Tuesday. Now let's get started. Complementary angles. If the sum of the measures of two angles is 90, then they are called complementary, and each of them is called a complement of the other. For example, we have angle A that measures 25 degrees and angle B with 65 degrees. If we add angle A and angle B, their sum is equal to 90 degrees. Therefore, they are complementary angles. Angle A is a complement of angle B and vice versa. According to the complement theorem, complements of congruent angles are congruent. Let's dig into that deeper. We will still use the example earlier, but we will add another set of complementary angles. Angle C that measures 25 degrees and angle D that measures 65 degrees. Okay, I want you all to pretend that angle B and angle D have unknown measurements. Based on given, angles A and C are congruent because they have the same measurement. If angle A is congruent to angle C, and angle A and angle C are complementary, and at the same time, angle B and angle D are also complementary, then we can say that angle B is congruent to angle D. Let's move on to supplementary angles. If the sum of the measures of two angles is 180, then the angles are called supplementary, and each is called a supplement of the other. For example, we have angle C that measures 40 degrees and angle D that measures 140 degrees. If we add angle C and angle D, they will have a sum of 180 degrees. Thus, they are supplementary angles, and angle C is a supplement of angle D and vice versa. If we have a complement theorem, we also have a supplement theorem. It states that the supplements of congruent angles are congruent. We have this diagram of angles. If angle A is congruent to angle B, and angle A and angle C are supplementary, and angle B and angle D are supplementary, then angle C is congruent to angle D. Supplementary angles may be seen as a linear pair or not, as long as the sum of the two angles are 180 degrees. We have been mentioning the term congruent. Let us dwell more on this. Two angles with the same measure are called congruent. Thus, angle ABC and angle DEF are congruent if the measure of angle ABC is equal to the measure of angle DEF. In this case, we write angle ABC is congruent to angle DEF. This symbol is pronounced is congruent to. Please take note that the equation of the measure of angle ABC is equal to the measure of angle DEF, and the congruence between angle ABC and angle DEF mean the same thing. As we have observed, there are series of relationships going on with congruence between angles, and it is an equivalence relation. It simply means that the equality between numbers has the following properties. First, we have the reflexive property. It states that A is equal to A for every A, or in terms of angle, angle A is congruent to angle A for every angle A. Next, we have the symmetric property. It states that if A is equal to B, then B is equal to A, or in terms of angles, angle A is congruent to angle B, then angle B is congruent to angle A. Lastly, we have the transitive property. It states that if A is equal to B and B is equal to C, then A is equal to C. Or in terms of angles, angle A is congruent to B, and angle B is congruent to C, then angle A is congruent to C. We have observed these properties when proving theorems on complementary and supplementary angles. Please take note of these study buds. It is very useful for proving. Next topic, vertical angles. They are pair of opposite angles formed when two lines intersect. As such, there are certain conditions. Two angles are vertical angles if their sides form two pairs of opposite rays. They are called vertical angles because they share the same vertex. And lastly, they are always equal. Vertical, by the word vertical, we refer to it as the vertex where they cross. It is not up or down. They are also called vertically opposite angles. For example, when two lines intersect, they form four angles. In the figure, angle 1 and angle 3 are vertical angles, and angle 2 and angle 4 are also vertical angles. In the figure, it shows that vertical angles are congruent, and in fact, this is always the case that will lead us to the next theorem. Vertical angle theorem. Vertical angles are always congruent. In other words, equal. They have the same angle measurement or size. To prove it, we have given that angle 1 and angle 2 are vertical angles. That is, 1. Ray AC and ray AE are opposite rays, and ray AB and ray AD are opposite rays. Therefore, angle 1 and angle 3 form a linear pair, and angle 2 and angle 3 form a linear pair. Angle 3 is congruent to angle 3. Angle 1 and angle 2 are supplements of congruent angles. By the supplement theorem, this means that angle 1 is congruent to angle 2. And there we have it. Vertical angles are always congruent. Another theorem states that if two intersecting lines form one right angle, then they form four right angles. To prove this, we have this figure. In the figure, the angle 2 is a right angle. This is given. We need to prove that angle 1, angle 3, and angle 4 are right angles. The main steps are as follows. Number 1. Angle 3 is a right angle. Angle 1 and angle 2 are supplementary. The measure of angle 1 plus 90 is equal to 180. Angle 1 is a right angle. Angle 4 is a right angle. There are certain theorems which we can use as the reason for steps 1 and 5. The reason for step 2 is a postulate. The reasons for steps 3 and 4 are definitions. From this, we can say that if two intersecting lines form one right angle, then they form four right angles. That's all for today's trip to Study World. If you are having problems with particular subjects such as math, science, English, Filipino, or social science, you can check Project Wala BI, link in the description below. Project UP will help you understand the topics you're having difficulty with. See you next time, Study Buds!